Hey, Jake here again, and this time we would like you to take the thermal challenge. And what that actually means is we have some of our windows set up in different phases of what you might encounter out at your house. We're going to have a window that we show designed for extreme heat. We have one that is designed for extreme cold, and we have one that's designed for extreme wind. Now I'll explain a little bit in depth of what we've actually done. If you can come in and zoom in, you'll actually see that our temperature inside of this room right now is really 120 degrees. These are 250 watt heat lamps. We have two of them in there, and if I open this, you will really find that it is 120 some degrees in there right now. We've got Barbie and Ken on the beach right now enjoying a little bit of beach scene. And what we're showing is, you put your hand here or a meter here, you'll feel that this is just regular insulated glass. Now this is what you'll find in about 85% of the houses that are out there right now. And you can feel that the heat's just coming through. This top sash, what we have is triple pane krypton. The gas between the glasses is krypton, which is a real heavy gas. Now, what this number down here represents is SHGC, solar heat gain coefficient. And that's measuring actually how much heat is actually coming through that glass. And this is combined with the coatings and the gas that goes into that window. Whether it's going to protect your drapes, it's going to protect your carpets, it's going to protect your furniture, and things aren't going to fade. If we were to take a piece of red cardboard paper or crepe paper and hold it behind this sash, in just a matter of a couple days or actually a couple hours, that would start to turn pink and eventually be white. If we put that same piece up on this piece of glass, you'd find that it's going to retain its color throughout the history, throughout the life of that piece of cardboard. So it's very important. Solar heat gain coefficient is a great number. The lower it goes, the better it is. So we showed heat here. This window is designed for extreme heat. We went to a total different route. We went to 180 degrees, and we went to a window that's designed for extreme cold. And if you zoom in here, you'll find out that right now we've got our polar bear in there with a frozen Coke. Those are frozen water bottles, and the temperature in there is right around 20 degrees. Now, it would be about 10 degrees if we turned the light off, but for this video we wanted to be able to see inside the freezer. Once again, what we're showing here is, this is triple pane, and the gas between the glass is krypton, the heaviest gas that you can use to make to insulate windows with. If I put my hand on this window, you're going to find that I'm just a little bit cooler than what the room temperature is, but you will see it's also 20 degrees inside. A real good test is when I raise this window and I tilt it in, I'm going to put one hand on this side and one hand on this side. It really is 20 degrees on the inside of this window, but it's right now about 68 degrees on the inside. So it's protecting that cold from coming through your house and inside of your house. And in the wintertime, it's also doing the opposite. It's keeping your heat from the inside of the house, and it's hitting this reflective coating and bouncing back into the house. And the cold is actually hitting the outside coating and shooting back outside. It works the same way for the heat and for the cold. This is also an insulated frame and a sash, which is helping to give us a U value. And this particular U value happens to be 0.17. This is one of the lowest U values that you're going to find of any replacement window out on the marketplace right now. The lower the U value, the better. It also raises your R value. But the best window in the world, if it's not made correctly, not installed correctly, is going to give you a problem with air. A lot of people don't want to talk about it because their air infiltration ratings aren't very good. The national average that you're allowed to have or to meet to sell a window in the United States is 0.30. If you look at our rating, our air infiltration rating is 0.02. So not only do we meet it, we blow it away almost by 3,000%. Now, what I have that I'm going to show here is I got some streamers hanging down in front of this these fans. I'm going to turn our fan on now. Step over here. I'm going to turn the fan on. What that's sustained inside is about a 60-mile-an-hour sustained wind. And if I had any air at all, it would be blowing around right now. But you can see the streamers and things are going from our two fans in there. So that's showing about 60 miles an hour. What I'm going to do let my streamers die down a little bit in here. Now I'm going to close this window again. I'm just going to shut it. I'm not even going to lock this. I'm not even going to lock this window right now. I'm just going to leave the locks open. And I'm going to turn our fan back on. That's once again about 60 miles an hour inside. Both fans are kicked on. If I take my hand around here, I cannot feel any wind at all. I can't even feel it at the check rail because of our interlock that we have. Now, one thing that you can put on here that will really impress you is if you have a sheer drape at your house, you know even when you walk by them, they move around. So I'm going to hang a sheer drape right in front of this 60-mile-an-hour wind. And remember, this wind is not even locked right now. I'm going to show you what it does. You're going to find that our curtain just hangs there. It's not moving whatsoever. And that's with an unlocked window. So our air infiltration rating being 0.02 is, now I'll even lock it. And you'll find it even gets better. I'll step back here while he's doing that. Okay. Okay. And now I'll turn this off. So, what we showed here today is our windows that are designed for extreme wind, extreme cold, and extreme heat. And you're going to see some of the lowest numbers of any windows that are manufactured on the marketplace. Thermal windows made the very first replacement window back in 1960. Still here in Pittsburgh, Pennsylvania. Still going strong, bringing on new products. And we just wanted to show you how our windows perform and actually outperform other windows.